Okay, today we're going to talk about how to graph a rational function. So we've talked about how to graph other functions. We've talked about how to graph parabolas when we have a x minus h squared plus k. When it's absolute value, it's a v. When it's a radical, it looks like, I don't know, a bit array, something like that. So we are going to get into graphing rational functions. So y is equal to a over x minus h plus k. Okay, where h and k are your asymptotes. Now asymptotes is spelled here, just so you know I'm not saying a bad word. And that's what asymptotes looks like. All right, asymptotes are basically barriers, invisible barriers where your graph cannot cross. That's basically what it comes down to. All right, so if we take this problem right here, I'm gonna give you an example of how to be able to do one like this. So the first thing you're gonna do is figure out your asymptote. So your x asymptote would be the number that cannot make your denominator 0, because in math you can't have a denominator that is 0. So my value that would make this 0 would be -3. So my x asymptote would be x equals -3. So at x equals -3, I'm going to draw a dotted line, straight up and down. My y asymptote would be what's on the outside here, which is -1, because if you cannot make this 0, then 0 minus 1 cannot happen. So my y asymptote would be -1. And those are basically, what I've done there is drawn invisible barriers of where my lines, or my graphs cannot cross. They can get really, really close to those lines, but they cannot touch the lines. It's kind of like high school relationships. You can get really, really close to somebody, but you can't touch them. So, if we're setting up an XY chart, same similar idea that we had with our XY chart when we were doing parabolas. We're going to have 5 points across. We're going to put -3 in the middle. There's no value for y. Then we're going to plug in the rest of our numbers. So this would be -2, -1. Notice I just went up by 1 each place. -4, -5. Now, it's not symmetrical. The value for -1 is not going to be the same as the value for -5. So all we're going to do is we're going to plug these numbers in for x and then find our points. Basically plug and chug type of thing. So if I plug -1 in there, I'm going to have -2. Y equals -2 over -1 plus 3 minus 1. So y equals -2 over 2. So y equals -1 minus 1, so y is -2. So I'm going to go here and plug -2 down. Then I'm going to plug -2 in there. So y equals -2 over -2 plus 3 minus 1. So y equals -2 over 1 minus 1. So y equals -2 minus 1. So y's value is -3. So we'll plug -3 in there. And then I'll keep doing that. We'll plug -4 in there. So -4 plus 3 minus 1 on the bottom. So it becomes y equals 2 minus 1 when you do it all out. So y is 1. And then we'll do the same thing for -5. Plug that in there and run out of space. So we do it over here. Y equals -2 times -5 plus, -5 plus 3. Is that right? Minus 1. So y is equal to -2 over -2 minus 1. So y is going to be equal to 1 minus 1. So y is going to be 0. Okay, and then there are our numbers. So then we go over here and we plot our points. So if this top number is negative, it's going to end up in the second and fourth quadrant, which is what this is, and so that's where it should end up. If the top number is positive, then it'd be like the first and third quadrant of your blue graph. So -5, 0. So -5, 0, that point is right here. I'm going to do this in red, it's a little bit easier to see. -4, 1. -4, 1, this point is right here. And again, we're getting really close to these lines, but we're not touching the lines. So we're going to continue to get closer and closer and closer and closer. But we're never actually going to touch it, okay? So -2, -3. So -2, -3, that'd be this point right here. -1, -2. -1, -2 is this point right here. So again, same idea. We're getting really close. And that's how you graph a rational function. I will take a picture of this. You have 10 of these problems on your homework. Let me know, please, if you have any questions at all. Have a great day.